Hi, my name is David, and I try to play guitar. I'm not very good, as you can tell. One day, I saw a video of blues great Joe Bonamassa getting very technical about his guitar amplifiers. For a guitar player, that guy really knows his stuff about amps. He inspired me to learn more. But to really understand guitar amps, you need to take them apart and put them back together. I watched hundreds of videos. I read all kinds of books. From Craigslist and eBay, I bought a used soldering iron, some old voltmeters, an ancient oscilloscope, and other test gear. Eventually, I built an entire electronics lab. Now, I guess I'm sort of an amp mechanic. I fix other electronics too, and this is my journey. I figured I'd share so others can learn too. I hope you like it, and just as a disclaimer, be sure to consult an expert before working with electricity. Hey everybody, Dave the Amp Mechanic coming to you from my amp lab in Boston, Massachusetts, where we're currently under the COVID-19 lockdown, social distancing from everybody. Most importantly, I have my COVID-19 lockdown hair going right now, as you can see. I haven't seen a barber in I don't know how long. And I thought, well, you know what? I'll just come on video with the COVID-19 lockdown hair, and I'll challenge any of you YouTubers out there that see this video to do the same thing. So, for example, one of my favorite videos to watch, or video personalities to watch, is Mr. Carlson. Noticed his hair is getting a little bushy. Terry over at D-Lab, another one of my favorites. Well, he's got his granddaughter cutting his hair. Brad the Guitologist still looks pretty well groomed, every now and then a little scruffy, but Brad, if you're watching this, let's see your lockdown hair. Okay, there's my challenge for now. This video is going to be about a Marshall JTM30 amplifier. This is an amplifier that is a combination solid state and tube amplifier, 30 standing for the supposed 30 watts. Usually that number is always going to be high. I'm not going to get into that for this particular video, but this amplifier is one that I acquired last summer. I saw it come up on the Facebook Marketplace. I happened to notice it like an hour after it showed up on the Marketplace, and it was being advertised for like $50, and I bargained them down to $35. Turned out it was a couple of parents whose kid went off to college, left the amplifier behind in non-working condition. They were moving and they just wanted it out of the house. So I raced down to get it, because I thought this is the ideal kind of amplifier for me to have and fix. Number one, if I can fix a $35 amp for like $10 in parts, well, guess what then? I can turn it around for a few $100s. This amp sells on Reverb for anywhere between $300 and $400. I can use that money towards something that I'm really looking to get, like a new guitar or something like that. Maybe some new gear for shooting video in my lab. There's all sorts of things I want to get, but I can't really afford unless I find a way to do this little side hustle and make some extra money. And I don't make any money shooting these videos. I don't have nearly enough subscribers. I don't think I ever will. So I really have to kind of figure out a way to buy low on some gear and sell high. And that's what I do with the amplifiers. Anyway, so I got this JTM30 back to my house, and as you can see, the first thing I'm going to do is I'm just going to pull the chassis on it to see what's wrong. But as you're also going to see, I got as lucky as you possibly can get when it comes to buying a non-working amplifier. So let's see what happens when I pull the chassis. Now, one thing we know about this amp is it's got these 6 screws up top here holding the chassis to the top of the cabinet. And if we feel around underneath here in the back, underneath the chassis, there are no side rails that hold or support the chassis up here. So you have to be very careful about unscrewing these without supporting the chassis in a way that the entire chassis just kind of falls out. So I'm going to turn this around. That way I can get my hands underneath there as I'm loosening it, so that when the chassis comes out, it doesn't just fall out. So let me turn this around. There we go. You want to make sure that any wires that are plugged, connected to the chassis, are unplugged. So, for example, this mono cable that's going from the output jack to the speaker inside the cabinet,
make sure that's unplugged, because when you start to take this down, you don't want to strain any of the wires or anything like that. So let's go ahead and take the screws out and remove the chassis. And it's very loose now. Alright, that should be it. There we have the chassis. And one thing that's really nice about the design of this chassis, by the way, here's where those screws go through. So you can see that was pretty much the only thing holding the chassis to the top. One thing that's really nice about this chassis is the design. And you can see how the tubes are mounted horizontally. So when the chassis is in there, they're not hanging down. So I can literally, and also look at this. This is kind of nice. This cage that's around the tubes is almost level with the transformer here, so that I can just, and the other transformer, which is on this side, so I can literally just set this on my bench like that without having to hurt any of the components that are hanging down.
Okay, now here comes the best part. Now that I've got the amplifier's chassis pulled out and I'm going to turn it around and take a look inside the cabinet, you're going to see just how amazingly lucky I got when this amp showed up here. Alrighty, well, I got really lucky with this amplifier, and you're going to find out why in just a few minutes. But first, I decided I was going to take the chassis out here. The chassis was up here so that we could get a good look at the back and see what we're about to do, but also you're going to find out why I got lucky. So looking at this amplifier, we can just see that the cabinet, the Tolex, is peeling, but it's not too bad. I just need to re-glue it down, and so I'll be doing that over here, up here, and then up here and along down here. You can see that this back panel, I'll just remove that back panel and glue it back on. And then over here we've got it pretty bad, but that's really easy to fix up. We don't have to take it out or anything like that. There's the reverb tank right there. But what I want to do is I want to focus your attention right here. This amplifier came to me, and it was from some parents whose son moved out, didn't want it anymore, and the parents were moving out of their house, and the father claimed that the amplifier simply didn't work. Well, guess what? Look at that. This connection is broken. The little spade connector on this is literally cannot hang on to that contact. It just comes right off. And that was the problem. I mean, it was as simple as that. I got this amplifier for what, like, I think $35. This amplifier goes for somewhere around $400 on Reverb. So I basically got a $400 amplifier for 35 bucks. And the main thing that was wrong with it, where the owners who sold it to me said it doesn't work anymore, was this. Now that is an absolute stroke of luck. So what I'm going to do right now is I'm just going to lift this one off here. I'll take this cable off, and then I'm going to resolder a new spade connector on there, and we'll put it back on. We'll fix up the Tolex here, and then we'll put the amp back together, and then we'll figure out what else is wrong with it, if anything, and we'll get it on its way. I'll probably sell this amplifier
and use it to either fund some new gear for the lab or buy something for my guitars or something like that. So let's fix this little connector here and put it back together. We'll put the chassis back in. I'll glue these up. I'm gonna spare you the trouble of having to watch me put some glue on. It's no big deal. I'll just use some rubber cement, and then hopefully we'll be on our way.
All right, so in this next bit, you're going to see how I've got the whole amp back together, and I'm like pretty excited about getting it working. And then something else goes wrong. Alrighty, so as you can see, I've got the new spade connector on this red wire here, and that was pretty simple to do. All I had to do was tin up the spade, then also strip this little wire down after clipping the old spade off of it, tinning the wire, putting the wire into the spade, and then soldering it up. It's very firm. When you give it a tug, it's not going anywhere. This spade is nice and tight. And I don't know if you can see this, by the way, but it's a 16 ohm speaker. I was just noticing that. I didn't even realize that when I first started working on the amp. And then the other thing that I did was I applied some contact cement, not rubber cement, as I said earlier, contact cement to the Tolex. So if we spin over here and we look over here, you can see that that Tolex is now flat down on the inside of the amp. And then if I can spin it this way, you can see that one side that was ripped earlier. And oops, my light is in the way of spinning the tripod. Let's spin it all the way over here. And there you go. So as you can see, hopefully over here, you can still see where the tear was, but the Tolex is nice and flattened down, and it doesn't affect the operation of the amp. But what, gluing all this Tolex down will do is make it easier to get the chassis in and out of the amplifier, because I have a feeling that's how it got ripped, was over time. That chassis has been removed maybe multiple times, and as a result of that, was like putting too much pressure on the Tolex each time it got pulled out. So now that we've got the Tolex repaired and the spade connector on the speaker repaired, the next thing I'll do is put the back door back on and put the chassis back in. One other thing I did, by the way, is I cleaned the Tolex all the way around the amp. As long as I had the back door off, I figured I'd do that. And I used just dishwater and a little bit of vinegar. That's something that I read up a lot about on the net, and it seemed like everybody was in favor of that way of doing it. So I've cleaned the Tolex up. I might do a little pledge or even some Armor All, figure out what I have laying around the house if I have either one of those things, to just kind of polish it up real nice. But right now I'm just going to get the back door on and get the chassis back in. I'll get the reverb tank reconnected, and we'll give it a whirl. Alright, well, here's the moment of truth with the amp. Let's give it a whirl with the guitar. I'm not the greatest guitar player, so I'm just going to give it a shot here. See what happens. That was the clean channel. It seems to be working really well. You hear a little hum here, and that's because I'm using my Telecaster. Depending on which angle I am standing, I get more hum or less. So you hear that? Those single coil pickups in that Tele. So let's give it a little reverb here and see if we get any reverb. reverb. So we got some good reverb going. And let's try the boost channel here. And as you can see, we're in the clean channel right now, which is green. And if I go like there to press that button to change the channel, it takes us into boost, which is the word that Marshall uses for overdrive or dirty channel. So let's see what we get here. Get a little gain going, get a little volume. So that's the gain channel. Take the reverb off of that for now. And then the last thing I want to test, and a little bit of a foreshadowing here, is that this is one of those amps that not only has the push switch to change your channel, but you can also plug a foot switch into this jack here, and you can change between the clean and dirty channel with the foot switch. So there's the foot switch right there that came with this amplifier. So let's go ahead and plug that baby in. Now let's give it a try. So we're in the boost mode now. Let's go ahead and take it out of boost mode with foot switch. And we have a problem. The foot switch is not taking it, switching between clean and boost mode. So the question is, what's wrong? Is it the foot switch itself, or is it something in the foot switch circuitry inside the amplifier here? So at this point, I clearly have something that's gone wrong with the foot switch. Now, these foot switches that toggle an amplifier back and forth between their clean channel and their dirty channel, I kind of have an idea of how they work, but I never really dug into it to really understand what's going on there in a way that I should as an amp tech. So I decided this is a great opportunity to figure that out, and once I had it figured out, to share that with you. So what I did was I made a separate video. I'm not going to make it part of this video. That's all about just that. And it's a pretty cool video because I take the circuitry, the schematic, and I actually do animations on the schematic. So up in the corner, you're going to see, I'm going to put up the, hopefully over here, I think I have my finger in the right place, but maybe it's not, maybe it's on the other side. But I'll put up a link to that video so that you can click over to that whenever you want and see just exactly how these foot switches interact with an amplifier. Now what's really important here is that the foot switch, when there is a foot switch with an amplifier, as there is with this one, usually the foot switch overtakes the functionality of the push switch that's on the front panel. And that's the part that I really didn't understand how it worked. So I go into painstaking detail. The video is probably a little too long, and I apologize for that, but I want to leave no stone unturned. So give that video a look if that's something you want to know about. In the meantime, we're going to come back here and we're going to take a look at just exactly what the problem is. So as you can see with the foot switch that comes with this amplifier, it simply doesn't toggle the amp back and forth between the clean and the boost channel. The clean channel is green, the boost channel is red. The foot switch does nothing. It's just staying on whatever channel I left it on with the push switch, which was the dirty channel. However, fortunately, I had another foot switch here in the lab. This one was a dual foot switch, and the left button on that dual foot switch is for working the channel of a different Marshall amplifier that I have to fix. And I decided to plug that in because that's a really easy way to decide or detect what the problem is. Is it the foot switch itself, or is it something in the circuitry of the amplifier? And as you can see here, clicking back and forth between the two channels very easily with that other foot switch. So now we know the problem is in the foot switch itself. So let's take the foot switch apart. Alrighty, so here's our sick patient here, the foot switch. And just to confirm that we have a problem with it, I've wired up my multimeter here so that I've got one side on the tip and the other lead on the sleeve. And as you can see right now, we're showing an open line. And when I click it, there's no change here. Even though I'm getting a really good action on the foot switch itself, this should switch to a very low ohms connection, because theoretically the pressing of this button here would complete the circuit between my red digital multimedia lead and the black over here. Now, just to show that if I just touch this here and close the circuit this way, there you go, a nice low ohms connection there, 0.3, 0.4 ohms. So what we have to do now is we have to figure out why this actual switch is not working. And my question is it possible for me to actually repair the switch, or must I get a replacement for the switch? And the only way we can figure that out is if we open it up. So this is where hopefully I will speed the video up so I can spare you the unscrewing of the screws here. But here we go. And there we go. We can see that it's not terribly complicated in here. And the wires look pretty well soldered here. Let me see if I can get close up on this for you. So it looks pretty good, but this is, I have a feeling this is going to be one of those switches that I'm not going to be able. So it looks pretty good, but I have a feeling that this is one of those switches that I'm not going to be able to open up and dissect very easily and repair. Let's go ahead and that's a, I don't know if you can see that, but look real close there. Done a pretty crappy job of soldering this connection here, the green wire to this, upon closer inspection. I mean, there's hardly anything in the way of a solder bulb there, and it's not even going through the little through hole here. So I do wonder, we'll get the multimeter back out here. Let's see what the multimeter says. Just out of curiosity. We'll zoom back out. And let's see what happens if I clip this one side of the multimeter. Let's get this plugged in here. Okay, and let's go ahead and just try this side over here. And now let's, for kicks, I'm going to basically push the switch by pushing the whole assembly down. All right. So the switch itself is working. What appears to be the problem is either the wire going out to the jack, or maybe these solderings here. Let's just see what we get in the way of continuity. Let's just see if we're getting continuity between these two things right here. Looks like we're getting continuity there, so it looks like they're connected. The next thing we would do is check whether or not there's continuity from, let me see if we can prop this up a little bit here so you can see it. There we go. Let me zoom in a little more. I'm going to bring this up some so I can get you a closer look here at what's going on. So the question is do we have a connection going out to the jack? And so I don't know which lead is the green and which is the red. I'm assuming green is going to be this lead here. So there's a low ohms connection from the green lead out to the tip. Let's check to see if we're getting the same thing on the red lead. So I'm going to clip that there, and let's go to the sleeve over here. And this seems to be a problem. So from the red lead to the tip, and obviously we're not going to get, and wait a minute. Okay, well, this is not making sense now. We have a that's because the switch is thrown. Let's do this. So we have a 1.1 ohm connection from the red lead to the tip. We have no connection from the red lead to the sleeve, okay? So the switch was closed at that moment. Now let's come back over here and check from the green to the sleeve. Nothing. Now what if we move my little guy here to the actual wire that's the green? Still no conductivity. So the green goes to the sleeve, and there is no conductivity from the green. Let's just try it one more time here. Let me use this guy here, or here it goes. So let's go from here. Just check one more time. Nothing to the sleeve, which is where it should go. Nothing to the tip. However, and this is the switch open position. we check the red lead, we'll see conductivity right there, but not to the sleeve. Okay, so the conductivity, I may have had that off camera, but the conductivity, clearly we have the tip to the red, not to the sleeve. And if we look at the other side of the switch, if we just kind of check the other side of the switch here, theoretically, if we close the switch, we should see conductivity at least to the tip here. So let's go ahead and try that. Yes. So I'm not connected to the wire. I'm connected just to the contact coming out of the push switch. So this is essentially telling us that somewhere between this end of the green wire and the jack is where we have the problem. So now what I have to do is I have to kind of figure out where that problem might be. The problem could be right in here, which I highly doubt, but I have to desolder this anyway, or maybe not. Or the problem could be at the jack end. There could be some damage here that we can't see, although looking at it visually, I don't see anything wrong with this. Or the last thing I should probably look at is, which I haven't looked very closely, is whether or not there is any damage along the cable where one of the leads got damaged. So let's get, we're all tangled up here, let's look for that first, because that would be a really easy fix. Take this off here, get the multimeter out of the way. Okay, and let's just kind of do an inspection on the cable itself. So I'll spare you the time it's going to take to run the full length of this cable. It's probably about 12 feet. So we'll speed the camera up here. Okay, so the cable looks to be pretty good, pretty good shape. Sometimes you end up with a problem near the strain relief over here. So it could be as simple as the problem being right there. So what I'm going to do next is I'm going to desolder these wires. I'm going to get the strain relief off, and then we'll get the wire out and we'll do another check on the multimeter. And then if it doesn't look good from here all the way to the end, what I'll do, the first thing I'll do is I'll just cut the wire right about here, because maybe something happened right in there, and give it another test and we'll see what happens. So let me heat up my soldering iron and I'll be right back. Okay, I've got my solder wick out here, and that's this stuff here. You see that? Love using this stuff. I also have a desoldering gun, and I don't need that. And I'm just going to go ahead and do some desoldering here with my soldering iron. Let's get that. You can see that solder wick just soaking up that solder. So this one's free. This one's not quite free yet. It's amazing to me that they just soldered the wires onto the top of the contacts and didn't actually put them through the through holes of the contacts themselves. I don't know if you can see that. Let's kind of get you up close there. The wire is just on the top. What a piece of crap soldering job that this is. It's amazing. Okay, so now we have to get the strain relief out. And for this, get my pliers. This can always be a little bit of a challenge. But essentially when you're working with a strain relief, and you can see that right there, if you can squeeze that down, that little nodule out, you can usually get it out. There we go. All right. So, and I might be able to reuse this strain relief. Should come right up here. There we go. So I'll get to reuse the strain relief, which is good. And now we have the two ends of the wire. And let's move the switch out of the way, and let's bring the multimeter back into the picture here. And let's zoom out. And put the backlight on so you can see it a little bit better. And just to double check, let's go ahead and see what happens when we look at the, where's the tip? Where's the jack here? Remember, red goes to the tip, so we should see some continuity to the tip, and I'll just poke this little guy out here. So there we see continuity to the tip. Now let's do the green side and try the sleeve. All right, so we have continuity to the sleeve there. No continuity to the tip. So this wire is actually pretty good. It was just a really lousy soldering job, if I'm not mistaken. And I don't know if you can see. I don't know if you can see here, but I'll bring the wire up. This end of the lead here, not a lot of light on that, I know, but it's a little, it's kind of a little rusty or something. It looks oxidized. So what I'm going to do is I'll just strip. I'm going to cut this back a little bit, strip some new wire out, resolder it up, and we'll see what happens. So I'll be right back with that work done. I need to put you through the stripping of the wire and all that, and cutting it down a little bit of length out here. So once I have that done, when I come back, we'll solder it up and we'll see if it brings the foot switch back to life. Okay, kiddos, I stripped the wire down, soldered it all up, got it back together, and it still wasn't working, and that really confused me. So I did a few more diagnostics and I believe I discovered the problem. So I'm going to hook one lead up here of my multimeter to the sleeve. There's the watchdog. And I'm going to put the other end right there. And watch what happens when I play with this wire right about here where I'm bending it. There we have a low ohms connection from the green lead up to the 1/4 inch plug. But if I bend it that way, it's a completely open line. Bend it back and it works again. So the problem is in this 1/4 inch plug right here. And what that means is I need to do one of two things. I can either save this cable, cut this 1/4 inch plug off, get a new 1/4 inch plug and attach it, and boom, we're in business, which is probably what I'll do because it's the lesser expensive route. Or I can just order a new cable that has a 1/4 inch plug on it, tip sleeve cable, and wire it up. So I'm going to save you the trouble of having to sit through that little repair because it's such a simple repair to apply here that it's quite obvious what needs to be done. You just need a new 1/4 inch plug and then we'll be back in business. Main thing is that the switch itself is very operational. So on that note, I think we'll wrap up this repair. All right, so now you know I didn't even have to take apart the foot switch, right? That was a bit of a rookie mistake. I should have just played around with the cable at first, and now I know in the future that before I pull a whole foot switch apart, the first thing I'm going to do is just test the cable, like twist it around a little bit and see if maybe it's just the cable itself or the 1/4 inch jack or something before I go taking apart the foot switch. Now in the end, I'm glad I took that foot switch apart. Why? Because I saw some pretty shoddy soldering in there, and who knows, at some point in time that might have come loose even though there was a strain relief on it. So I'm glad that I took it apart, put it and fixed that soldering and then put it back together. But now, of course, I have to replace the cable. I'm going to spare you the details of that because it's just a cable replacement, really easy to do. And in fact, I might just take put a jack, a 1/4 inch jack on the back of the foot switch in a way that you can just use a standard guitar cable between the foot switch and an amplifier. That'll make it a lot easier. But I'm not going to really go into that part of the repair for you because it's such a simple repair and there's a million videos on how to do that out there. It's pretty simple and straightforward. Best part of this is the amplifier is working. I know what the problem is with the foot switch. Can move on. I'm going to get this all put together and then I'm going to turn it around and I'm probably going to sell this amplifier and use that money to buy something cool for either my guitar setups, my amps, my guitars, maybe a foot pedal or something like that I need. Or I might buy some more gear for my video studio because I'm always looking for ways to improve how it is I do those videos. So thanks for joining me. I'm Dave the Amp Mechanic from my Amp Lab in Boston, Massachusetts. I'll see you at the next video.